let us look at this second example. The National Center for Health Statistics report that the systolic blood pressure for males 35 to 44 years of age has standard deviation 15. The medical director of a very large company looks at the medical records of 72 randomly selected male executives in this age group and finds that the mean systolic blood pressure in this sample is X bar 126.07. Estimate the mean blood pressure for all executive males 35 to 44 years of age using 90% confidence interval. So what you want is that you want 90% confidence interval for mu, for those executives from the age 35 to 44. So in this, so you pull a random sample size is 72, the X bar is 126.07, and so then we already know that this is the interval, CR power 2 sigma over square root of n, and with the plus sign. Alright, so now we need to check whether we have the right condition, right assumptions to do this question. So the first one, the initial population. So initial population must be normal. Okay, so here so in this question, if you read carefully, it doesn't say that these blood pressure values, they are going to follow a normal distribution. It does not say that. So that means, so we do not have this part. But even though we do not have that, see, n is 72, is quite large. So this part is okay. So therefore, this assumption is fine. Okay. So because of that. So 1 is good. So the 2, so the sigma equal 15. So that is, so it says that standard deviation of 15. So which means, so that is given. So we don't need, this is good too. All right. The third condition is that random sample. Does it say that it's a random? Yes, it says that they pulled 72 executives randomly. So this is random as well. So all three conditions are good. So therefore, we have the correct assumptions. So now, so here X bar value. So it's a matter of using this formula now. So X bar value is 120. So answer for part A, 126.07 minus for the 90%, 1.645 times the sigma is 15 divided by square root of 72, and so the same thing with the plus sign. All right, so here this value is going to be 126.07 minus 2.90798, that with the plus sign. So this is going to be 123.132 all the way up to 128.94798. Okay, so that's the confidence interval. So say for example, if you want 90%, change that number to 1.96. Okay, the margin of error, so that is the part of the margin of error right there. Okay, so the answer for part B, practical interpretation, this B is this B. Okay, so the interpretation is the same way. If you keep pulling random samples, 90% of the time, you're going to get your unknown mu value would be within the margins you are going to get. Okay, so the part C, exactly the same way. Part C, basically for 80%, you need to get the Z table value, just like in part A, in the previous example, CR power 2, this is 1.28. Okay, so my important part is that the part D, I already did that. So checking the assumptions 1, 2, 3. Okay, so we already have all the assumptions. That means we have a good estimate. Okay, part E is the one I need to do. So part E, so here if sigma is unknown and S value is 14.5, can you give a confidence interval for mu? So in other words, what I am saying is that suppose this 15 is not given in the question, and right there in the sample x bar is that and S value is that too. That is given there right in there. Suppose that is the case. In other words, this is unknown and S value right there, that is given 14.4. So can you give a confidence interval for mu? You remember that when we were doing part E in the previous example, I said that you cannot do it. You have to wait for the next chapter. Okay? Because n was 3. Okay? Let us see what will happen here. So here now sigma is unknown, but if you look at that condition now, the condition, so you can replace the unknown sigma by S if n is quite big. So in our case, so it's 72. So that means it's quite big. So that means, so this is unknown, that is correct, but I am going to replace that thing by S. We can do that because n equals 72. Alright, so still we can maintain a good result. Okay, so that's the logic. Okay, so you can kind of accurately estimate this thing by S. So in other words, I'm going to use the same formula like here, this formula. Instead, sigma I'm using right there, I'm using the S. So in other words, I'm using the x bar minus the CL power 2 S over square root of n, the plus sign. Okay, so this is going to be, so if I'm dealing with a 90% confidence interval now, okay, so this is going to be still 126.07, and this part is stay the same, 1.645 times the S value now is going to be whatever that given value, 14.5. 14.5 divided by square root of 72. That plus, okay, this right there plus sign. So here this is going to be 126.07 minus 2.8110. So that thing that, so it's 123.229, and this is 128.8510. All right, so this will so we can do that, so because n is quite big. All right, so let us go to the third example. So the third example, if you by the way, in this question I need to make a point here. Okay, so if this part is given right in there, when you do part A and C, you do not use this value for part A and C. Okay, you still have to use that 15 even if that is given in right in there. Okay, because that 15 is the right value for sigma. This is just an estimate for sigma. Okay, don't make that mistake. Okay, all right, so the third question. So in this question, you guys read the question, is basically you have 50 values. You want to construct a 99% confidence interval for mu. So if you read the question carefully, it doesn't say that this population is a normally distributed population. So in other words, initial population could be anything, okay? But the n equal 50, that's a quite big sample, okay? And according to this, these are continuous values, random variable. So also you might want to check that sigma is not given either. So I'm going to replace this thing by S. So what you need to do is that you punch these 50 values into the calculator and use the calculator memory to figure out the x bar as well as the S. So you're going to get those two values. This is the sample standard deviation, okay? So use the right key with your calculator. So sample standard deviation, sample mean. So I'm going to replace the sigma by S, and so this is that. So with 99, I need to figure out, let me look at the assumptions now. So the assumptions, they are correct, right? Because the initial population, that is not given. Even though that is not given, n equal 50, this part is all right. And sigma is not given. Even though that is not given, n is 50 again. That is okay too. I can replace sigma by S. So again, that is a random sample according to the question. Okay, this is a random sample. So therefore, everything is good. Okay. So it's a matter of now figuring out for 99% Z table value. So from the Z table, so from here to here, you need to cover 99%. Okay. So in other words, as a probability 0.99. Okay. So if you split that into 2 from centered around, this is symmetric. So this part is going to be, okay, half of that, 0.495. So either that is 0.495 or this part, this and that is going to be 1%. So this is going to be this part alone, 0.01, 1% divided by 2, 0.005. Okay. So if you look at this value, either right here or right there, this value is going to land inside the Z table. For this value, it's going to be 5 in between precisely two values, 5.75 and 5.76. So I'm going to take the average, not 2.57 and 2.58, okay, 2.575. 2.575, okay. So take that the average. So then 2.575, okay. So that's the Z table value. So in other words, this is a Z alpha over 2. So in the formula now, so use those values, the x bar minus the table value and the S over square root of n, all right. So the x bar, which is 20.85 minus the table value 2.575 times the S value 13.41 divided by square root of 50. So that. So calculate that and that. So that is your answer. Okay. So the assumptions what we are making is that, so basically this is a big sample. That's why we could have done it even though we do not know anything about that initial population. Initial population probably may not be quite normal, but still this sample is a very big sample. Okay. So in the next chapter, what I am going to do is that, what if I am going to do, say, this example. So instead of having 50 value right there, what if you are going to do if you have 5 values? In other words, rather than having 50, you have only 5 values. Can you answer the same question? Okay, that's exactly what we are going to do. Sigma is unknown, but can I answer this question with having 5 values? That's what we did over there, okay? I said that over there. I'm going to do it later. So that's what we are going to do, okay? Sigma is unknown. We are going to, basically, the idea is that we are going to replace the sigma by S, but we are going to use a different table, okay? I will give you the theory in a second, in the next, section, okay? Or the next chapter. Okay.